About a year ago, I gave a talk on searching for life in the solar system and what was going on. And since then, there have been some interesting developments. So I thought I would follow through with some of those developments and also expand the sphere of searching to the entirety of, well, not the entirety of the universe, but to the nearby parts of our galaxy where we're beginning to be able to look for signs of life. And also because we're looking outside our solar system, we can talk a little bit about searching for intelligent life, quote unquote, and also the question of exactly what it means to be intelligent life and how would we even recognize it. We tend to see things very much through human colored glasses. Oops, everyone all right back there? Okay. We tend to see things through human colored glasses, and it's an interesting question as to how to recognize a civilization. Do we need to look for like timeshares and Pop-Tarts and like robocalls and flow from progressive and weapons of mass destruction or reality TV shows to call a civilization intelligent? Are we smart enough to even recognize intelligent? This planet over here, by the way, is Beta Cardassian b. This one is Rose Snoopier b. But anyway, let's start with just plain life and stay within the confines of the definition of, quote, life as we know it, end quote. Scientists and spinners of fabulous tales and conspiracy theorists and dreamers of all kinds have been speculating about the existence of life elsewhere in the universe for millennia, literally. And scientists have been searching actively for a couple of centuries, but like I noted at the beginning of the last talk I gave, searching for extraterrestrial life is like being a Mets fan. By the way, if you're a Mets fan or a Yankees fan and you're old enough, you should recognize this famous baseball moment, Luis Castillo. There are tantalizing glimpses of success streaming in from probes and space telescopes, and you think some great revelation is at hand, and then it always seems at the last minute some great cosmic Luis Castillo drops the ball, right? So let's examine a few of those great exobiological disappointments. First of all, most famously, Percival Lowell and the canals on Mars, which he was convinced he saw in his telescopes. That myth was put to rest by the Mariner probes in the 1960s. The Viking mission and its discovery, still possibly true, of microbes, water and organic molecules, which have been picked up by subsequent Mars probes, but also perchlorates, which on this world, chemical compounds that are inimical to almost all life. We had the thrill of finding phosphines in the atmosphere of Venus, but maybe we didn't. There was the meteorite in Allen Hills, the Allen Hills meteorite, I should say, from Antarctica, which had come from Mars originally and which appeared to have microscopic life in it, fossilized. That proved to be, it was taken seriously enough so that President Clinton announced it to the world. He had his own disclosure day, but it turned out to be fake. We've had the WOW signal and beacons from Proxima Centauri and the Dyson sphere around Tabby's star. All of those things proved not to be convincing evidence of life. But you'll notice that those disappointments fall into sort of two distinct classes. Some of them are just flat out wrong, like the canals on Mars, while others are revealed to be phenomena that could conceivably be caused by non-biological processes. But there's a big difference between flat out wrong and something that's being suggested but insufficient proof of life. And examples of the latter category are beginning to pile up, and we'll most likely not definitively discover extraterrestrial life in our lifetimes, even more likely so in mine. But how many bits of suggestive evidence, how many maybes need to pile up before we have enough to make a problem. Right? Not be sure, but not enough, in other words, to get a verdict, but maybe enough to get an indictment, unless you're the Justice Department. Sorry. So let's start by going over some of the ground I covered in my last talk, some of the new evidence that's coming in from our own solar neighborhood. There are some interesting developments with that. Later on, we'll talk about looking at other stars. And then we're also going to talk about intelligence here on Earth, just as there is some, just as an example of how difficult it is to categorize or define intelligence. There have been some interesting developments. Let's start with Venus. It's seemingly not a great place to look for life. As to most people, it's pretty much the closest approximation in the solar system of where you go after you die if you haven't led a virtuous life. Not IKEA, but Venus, right? So Venus is a place where the temperature is in the vicinity of like 900 degrees Fahrenheit.
That's too warm.
Its day is, our online guests should mute themselves, by the way. Its day is about 243 Earth days, but its atmosphere circles Venus every 4 days, so it's also got very high winds. The surface pressure, as you can see, is about 1,350 psi's, roughly equal to the pressure 1 kilometer below the surface of the sea. And if you think about the Titan Explorer, that'll give you an idea of what that pressure might be. That's a little more than 1 kilometer, but still. The winds keep the temperatures constant so that the nighttime and daytime temperature vary less than 5 degrees Fahrenheit, which is pretty amazing considering we're talking about 900 degrees and a night that's 120 days long. And there's no water. So the habitability quotient is, like it says there, less than or equal to Philadelphia. And yet Venus's atmosphere is another story. If we look at this chart over here, I'm going to have to use the cursor for this so people can see me. This chart's temperature in degrees Kelvin, that's significant, against the altitude and the pressure. So at about 50 kilometers altitude, the pressure is equal to 1 Earth pressure, and the temperature is just above 300 degrees Kelvin. So 300 degrees Kelvin, we're talking roughly like regular nice day temperatures here. This Kelvin is the scale that has centigrade size degrees, but starts at absolute 0. So it's fairly warm. It's nice and livable. Of course, you have to be light enough and or small enough to float. But Lando Calrissian can do it. So why not some hypothetical Venusian life? Any of you people are like crazy Star Wars people. The trivia question of the day is, what is the name of the planet where that cloud city is located? I can divulge that answer later. But exobiologists have some hope for Venus. And the reason is because of phosphine gas. So phosphine gas is one of the reasons, but it's controversial. Phosphine the molecules of phosphine are made up of 1 atom of phosphorus and 3 atoms of hydrogen. And in 2020, a group of scientists led by a woman from Cardiff University, Jane Greaves, published a study suggesting that they discovered a large quantity of phosphine gas in the Venusian atmosphere. The Met fans among us, metaphorically speaking, all got tremendously excited by that because phosphine, according to the CDC, I quote, is a colorless, flammable, and explosive gas at room temperature that smells like garlic or decaying fish. Exposure to phosphine may cause nausea, vomiting, stomach pain, diarrhea, thirst, muscle pain, difficulty breathing, and fluid in the lungs. So you may wonder why we got excited. Well, phosphine on Earth is associated almost entirely with microorganisms in anoxic environments, places where there's not much oxygen or any, like the peat beds underlying salt marshes, which is why, if you want to understand what phosphine smells like from a safe distance, you are in the best place to do it. I recommend Carteret. Or if you like something more pristine, maybe, like the Brigantine National Wildlife Refuge, where there's lots of nice salt marsh there. In fact, if you've ever been to MetLife Stadium, that whole area kind of reeks of faintly of phosphine gas. And I don't need to say what it says there about New Jersey being something that broke off of Venus and fell to Earth. So the phosphine gas in Venus's atmosphere proves Venus has life, right? That's why we all got so excited. But of course, skeptics in the scientific community attacked this excitement from two directions. One problem was that Greaves's results were not repeatable. There was actually not any phosphine gas in the Venusian atmosphere, at the very least, much less than the Greaves study suggested. And the other problem was that mechanisms that weren't dependent on biological processes were discovered and pointed out, which could result in the presence of phosphine. So that's kind of like the equivalent of the food is bad and the portions are too small, right? I mean, the results couldn't be repeated and they don't mean anything. So it was sort of wait until next year. But what happened was that Greaves came back a couple of years ago and announced that she discovered phosphine in the atmosphere again using data from the James Clerk Maxwell scope on Mauna Kea, and that the problem was that it was deeper in the atmosphere than her initial paper suggested. I'm a little suspicious of this because it comes from the same scientist who published the initial study and therefore kind of smacks of I need to vindicate myself syndrome, kind of. But at this point, we have to say that the phosphine controversy isn't dead yet. It's a maybe. And another thing about any hypothetical Venusian life that's kind of interesting is that it might not represent a second genesis of life. It could be us. We'll talk about this more with relation to Mars, but there is a hypothetical phenomenon called panspermia, right, where life is spread from one planet to another by means of collisions and small fragments of with microbes in them being belted from one place to another. And such a thing could have happened. It's known that collisions between, we know about lots of collisions between planets and asteroids that threw lots of stuff way up into the atmosphere and possibly launched some of it into space. There was one fairly notorious one about 66 million years ago, but there have been several before and since. So that splatter might have space mailed Earth life to Venus, or conversely, Venusian life to Earth. And the infamous, I referred to it before, the Allen Hills meteorite from Antarctica is maybe the most famous example. It came from Mars. That's what was so exciting about it. So we knew by comparing it to Martian samples that it was something that came from Mars. So even though what was in it proved not to be life, it did prove to be something that was airmailed to us from another planet, and we have discovered many asteroids here on Earth that came from other places. So maybe some bits of rock sent into space by one of the millions or billions of collisions in our history ferried some anaerobic bacteria to Mars or Venus. In Earth's early history, all life was anaerobic, by the way. And the unwitting pioneers took root in Venus's clouds. So we met the aliens and they as us. But that's still a pretty interesting proposition. And the new development of this is that it's interesting enough to finance what is going to be the first privately funded mission to another planet, being done by MIT in collaboration with the New Zealand-based company Rocket Lab to produce the Life Finder mission. And there it is. You can see that being done commercially. It's being done on the small and done on the cheap. It's a tiny capsule that would be dropped into the atmosphere from a slightly less tiny mothership and transmit data up to the mothership to be linked back to Earth as it falls through the Venusian atmosphere. And it will eventually fall to the surface where it will be crushed, baked, and corroded away by Venus's famous sulfuric acid rain. But maybe first it will give us some definitive answers. Of course, probably not, but maybe. And so, if Venus is the red-haired stepchild of the exobiology world, Mars is the fair-haired son. Despite being hellish in its own way, it appears to be dry, it's cold, it's geologically dead, and there's no atmosphere, or very little atmosphere, I should say, to speak of. And yet, Mars has been the great hope for extraterrestrial life since basically forever. Certainly since Schiaparelli in the 1880s thought he saw water-filled channels while observing the surface of Mars through about a 9-inch refractor. So he was observing Mars through a telescope about the size of the 10-inch refractor in the dome over there. If you've looked at Mars through that refractor, then you've noticed that the details you can see on an exceptional night are maybe the polar ice caps, which, by the way, are carbon dioxide ice, and the surface features, like the Valles Marineris, which is a canyon that here on Earth would stretch from Sperry Observatory to Boise. So it's an extremely large detail. And that's probably what Schiaparelli saw. Of course, a canyon is a channel of a sort, but more on that later. And then about a decade later, the American Percival Lowell mistranslated the Italian word for channels, canali, into canals, and took it as a sign for intelligent life. And he looked through his telescope at Mars and mapped thousands of miles of canals on the Martian surface. He was certain he saw them. He mistook the dust storms, which occasionally cover the surface of the planet for seasonal vegetation. And to top it all off, he decided that this meant that Mars was home to a dying civilization, desperately channeling its last resources into getting water to its agricultural fields. Such is the power of anthropocentrism, and such is our need not to be alone in the vastness of the universe, that Lowell's very dubious observations and the Jenga tower of deductions he built atop those observations were found in the journal Science and were presented as legitimate theory right up until like the 1960s. I can remember children's books growing up talking about Martian vegetation. The image of that dying Martian civilization has suffused throughout our culture. It appears in the works of Edgar Rice Burroughs and Chuck Jones, as shown here, and of course H.G. Wells, and 1,000 other works of pulp fiction. It taps deep into a kind of a sociological facet of our species, that we think, our world doesn't work anymore. Their world doesn't work anymore, so they're coming for ours. And you can see that archetype reflected into today in works like The Three-Body Problem, for instance, if you've read that or watched it. In the 1960s, this fiction finally blew up, at least as it pertains to Mars. The first interplanetary probes revealed that there were no canals, no vegetation, almost no atmosphere, and no nothing. The canals had been an optical illusion, the vegetation was dust storms, and the dying civilization, again, was just a tower of faulty assumptions built on quicksand. And yet, cultural memes run deep, and we continue to be fascinated by Mars. We sent a lot of spacecraft there, and it's a good thing, too. It turned out Mars was once geologically active. It once had a great deal of water. It probably once had an atmosphere. It may indeed once have had life. And just might still, if for no other reason, that our study of Earth biology has shown us that life, once it gets started, finds a way. So a series of probes have given us both discouraging and positive results. Some of the positive tests have been debunked, but most of them are simply insufficient. In other words, they're accepted, but maybe there could be some alternative explanation. And those maybes, again, are piling up. So the Mars Reconnaissance Orbiter and Curiosity and Perseverance rovers have found organics and clear evidence of past water. The latest news from Perseverance is maybe the most promising development in exobiology yet. Exobiology, or at least exopaleontology, may actually be a legitimate field. Perseverance has been exploring an area known as Jezero Crater. That's where it landed. And it was thought to be an ancient delta and appears certainly to have been that. And here are some of the sites that it's visited, places with names like Chayava Falls, which is the one we want to focus on, Grapevine Canyon, and my personal favorite, Mount Spoonhead. I would certainly like for life to be found in Mount Spoonhead. But at any rate, in Chayava Falls, Perseverance found a rock about 3.5 billion years old, dotted with these little features called poppy seeds and leopard spots. Poppy seeds are kind of all over. The leopard spots, you can see a couple of them here. These features were found to contain hydrated iron phosphate, also known as vivianite, and iron sulfide, also known as gregite. On Earth, these minerals are most frequently associated with life. Vivianite is often found in areas of decaying organic matter, where there once was decaying organic matter, and gregite is also associated with past microbial life. This is not proof of life, but these minerals are frequently the result of chemical interactions between life and elements like iron, sulfur, and phosphorus. So what is a very suggestive and intriguing maybe has been turned up by the Perseverance rover. And the good news is that Perseverance has been collecting samples and leaving them in little containers for us to collect on a later mission. So we might get proof, except for the fact that our hopes have been dashed again by NASA's planned mission being canceled due to the great expense and difficulty. So maybe we'll get to them in a few decades, or the Chinese or Mr. Musk will pick them up. But I'm not holding my breath. Meanwhile, poor Perseverance, like a character in a Beckett play or something, keeps dutifully packing up rocks and leaving them to be found, kind of forlorn. But it is kind of the most encouraging evidence found yet. And people have not yet been able to come up with some alternative explanation of how those leopard spots may have come about. But this creature, of course, is a tardigrade. If you've not heard of them, I just wanted a picture of hardy Earth life. But this is a not microscopic, but very small animal that you can find. It's sometimes called a moss bear. So you can find them in your backyard. If you have moss in your backyard, they're like 0.5 millimeter long or something like that. They just were discovered to be incredibly hardy. And they are not exactly extremophiles, but they are extreme survivors. They can survive being dehydrated. They can survive being frozen. They can even survive being exposed to the vacuum of space, because lovely creatures that we are, we have done that to them. They have been exposed to the vacuum of space for a while, then brought back to Earth, revived, and they have successfully bred. So tardigrades are kind of amazing, but the fact is that life on Mars, the point I want to make, should it prove to exist, just like life on Venus, might turn out to be us. Bacterial cousins blasted from Earth to Mars, or vice versa, panspermia again. that would be a bit of a letdown, as we would love to find a second Genesis, but there's also a very comforting side to it. Life has proven to be incredibly hardy once it gets its foot in the door, like this tardigrade has shown us. Um, and the thing is, if life is that hardy, then maybe it's more widely spread than we dared hope. Uh, because even in some other system, so maybe some rocket was blasted into interstellar space, has been captured and landed somewhere. In recent decades, we've also expanded, thanks to discoveries by our spacecraft, that life could be existing in areas where we previously thought it to be impossible. We always had this notion of a Goldilocks zone, but it's beginning to look like life could exist outside the Goldilocks zone in a large number of moons and dwarf planets where we have liquid water, sometimes in large quantities, in subsurface storage. So you all know the usual suspects, and many of them are pointed out here. The two most notorious ones are Europa, which is a moon of Jupiter, and Enceladus, which is a moon of Saturn, which I am looking for there. It's very tiny. But both of those are known to be sort of like the opposite version of a big tornado. They are an ice shell with a water interior, kept liquid, probably by tidal energy, and with a solid core to provide some sort of chemical nutrients. The problem, and then subsurface oceans already exist, bless you, on Ganymede and Callisto, Titan, which we'll talk a little bit more about in a second, Saturn. Some water is known to be on the moon, but another really interesting place is the dwarf planet Ceres, which is in the asteroid belt, where there seems to be some subsurface liquid as well, very grimy. And then Titan is a really interesting place. It's the largest moon of Saturn. It not only seems to have a subsurface ocean, but it also definitely has an atmosphere as thick as Earth's, which is the only moon like that. And on its frozen surface, it has lakes on the surface of Titan, water is a rock, but it has lakes of ethane and methane, hydrocarbon lakes. It could conceivably be like a single body with two different geneses, water-based life underground and some sort of weird hydrocarbon life, as we don't know it, up top. That's the stuff of a good science fiction story, if anyone's interested. But the problem is, again, that it's super challenging and expensive to get to all of these places. So there's no new news since the last talk I gave. However, some help is on the way. You may know there's a mission currently en route to Europa called the Europa Clipper. We had a speaker about it last year. And this chart is a little bit out of date because some of these things have been launched and some of them have been scrapped. There's also a planned mission to Titan, which we had a talk on last year, but it hasn't been launched yet, and it's not certain that it will be, called Dragonfly, which is super cool because it's going to be an aircraft. It's going to land, we already landed a little helicopter on the surface of Mars, but Mars has almost no atmosphere, and getting an aircraft to work in a place, getting a helicopter to work in a place where there was no atmosphere or very little atmosphere. Mars's atmosphere is what, about 100th the density of Earth's or something like that. Getting a helicopter to work there was very difficult, but they did, and it worked beyond their expectations. So on Titan, where there's an atmosphere as thick as Earth's, could really be launched and travel around there, and could do some very good exploring. That's on the way. Maybe somebody else will come and get our samples back. I don't know, but there are other missions, as you can see, to the outer planets, Tianwen-4, scheduled for 2029 by China, is scheduled to examine Callisto and also fly by Uranus, which will only be the second time we visited it. So who knows what we might discover there. So that's a little bit of an update on the solar system, but how will we ever know if there's life on extrasolar planets, let alone intelligent life, until someone invents a warp drive? The nearest star to our sun, Proxima Centauri, according to the latest measurements and my calculator, is 24,690,000,000,000 miles away. That's 4.2 light years. The Voyager 1 probe, which was launched in 1977, when Saturday Night Fever was a big hit movie and I was a senior in high school, and currently traveling at 38,000 miles an hour, will travel that distance, 4.2 light years. Let's see, so it's Friday, it's about 9 o'clock, 75,000 years. Collecting samples from other stars is unlikely in our lifetimes. There are some obstacles. However, let me remind you that in 1835, the French philosopher Auguste Comte said that there were limits to human knowledge, just like I just said. And as an example, he said something along the lines of, at any rate, we'll never know what the stars are made of. Within 2 decades, we knew what the stars were made of his saying that. And in fact, the means by which we knew what the stars were made of had already been discovered when he said that by Josef Fraunhofer in the early 1800s. I'm referring to the science of spectroscopy. I want to see if I've gotten behind my slides here. I'm sorry. I don't think I have. So spectroscopy is when you use a prism or a grid to diffract white light into a spectrum. And if that light is coming from a star, you can look in that spectrum to see where there are bumps in brightness or dark lines where there is no color. And those would show, respectively, how light of a particular wavelength is being radiated or absorbed, and that way we can know what the stars are made of, because the specific wavelength is being absorbed. One new element, already by 1868, was discovered in the sun when a balloon-borne spectrum of the sun was taken. Even though that element was later found out to exist on Earth, it was hitherto unknown because it didn't react chemically with anything, so it was named for the sun, helium. And it was only discovered on Earth after it was identified via spectroscopy. So this same process of spectroscopy is used today with vastly more sensitive instruments to trawl for life signs on other planets. You would expect a planet with life as we know it to have an atmosphere, and you would expect water vapor, free oxygen, carbon dioxide, methane, and some other elements to be present in that atmosphere. Now, you can't look directly at another planet. They're really far away. They're close to some star that's going to be much brighter than they are. However, if the path of that exoplanet's orbit transits its star, as seen from our point of view, in other words, if it goes right in front of the star, we can take a spectrum of its atmosphere backlit by the star and compare the spectrum to that of the star itself. And by subtraction, we can figure out what's in the star and what's in the planet. So here's a sample spectrum. You can see the absorption lines representing the presence of methane, carbon dioxide, ozone, which is triatomic oxygen, molecular oxygen, and carbon dioxide. Lots of carbon dioxide there. Two things. As you can imagine, instruments of extreme sensitivity and accuracy are required. This was one of the primary missions for which the Webb Space Telescope was designed. Second, this spectrum is a simulation. If astronomers have actually found an exoplanet with this spectrum, you'd know about it, because this would be front page news for months, because this is almost surefire life sign. Any world with this spectrum would be occupado, right? But some interesting spectra, I should say, have been discovered. These are real spectra from two stars called WASP-39b and K2-18b. We can see in their spectra methane, carbon dioxide, dimethyl sulfide, known according to Wiki for the distinctive aroma. And all of these substances are byproducts of biological processes here on Earth. And WASP-39b, there appears to be a clear indication of the presence of water as well. All that's missing is oxygen. Oh, that's too bad, though, right? That's a deal breaker. Well, no. We know of at least one planet where life definitely existed for hundreds of millions, maybe billions of years, when there was no oxygen in the atmosphere. That planet, of course, is Earth. Like it says on the slide, the fact of the matter is we don't know of a way by which a planet could have free molecular oxygen in its atmosphere unless it had life. And the oxygen in our atmosphere came from photosynthesizing cyanobacteria. And it happened about 2.4 billion years ago and caused what is called the Great Oxygen Catastrophe, which wiped out most of the life that was then on the planet. Photosynthesis, photosynthesis bad. Of course, it's not bad, but it changed the world. So the life had to evolve first. Of course, we don't know for sure that we're looking at a baby biosphere or maybe like a Peter Pan biosphere that's never going to grow up. But again, maybes like this are piling up. So we have that again. So, okay, maybe we can find signs of life from light years away, but what about intelligence? I mean, if they're not actively trying to contact us with lasers or focused transmissions, assuming they even use them, and assuming they want to contact us, how would we know they're there? Regular radio signals or beams of light would be far too diffuse by the time they reached us. Well, it turns out we can use spectroscopy for that too. There are things that wouldn't be in the atmosphere of a planet without technologically advanced life. But is that the same thing as intelligence? Stay tuned for that. But chlorofluorocarbons, for instance, or PFAs, another industrial pollutants, gain fresh scent, hydrogen sulfide, although that can also be produced by non-biological processes. But we can look for technosignatures in the atmosphere of planets. Needless to say, we haven't found a promising candidate for this yet, because if we had, again, you'd know about it. But you do have to wonder, do we really know what intelligence would look like? Or are we blinkered by our own anthropocentric, technocentric view of things? Would intelligence necessarily be technological? And would non-technological intelligence be just as fascinating to me? By the way, I guaranteed last week that you'd see this picture of this. Right? He's like, this is the obligatory picture of Jodie Foster in Contact. But it's pointing up how much our anthropocentrism blinds us. We had discovered radio astronomy, and all of a sudden, all we could think of was that alien civilizations would be using radio waves to contact us. And so all of these large observatories, like Mount Arecibo, blessed memory, were built with that idea in mind. But did they think that that was the end? That nobody would advance beyond that? I don't. Nobody seems to think that this is the way we're going to find intelligence anymore. With apologies to Jodie there. or have we met intelligent life already? And are we interacting with it already? Dogs may not seem like the most intelligent creatures out there. They chase their tails and eat weird things, but they are far more adept at reading their environment than we are, and are able to negotiate complex social hierarchies better than many scientists and musicians that I know. They can certainly understand the limited vocabulary, not just the words, but inflection and all the other ways we have of communicating. Gorillas and chimps, like Coco the gorilla and Washoe the chimp, both pictured here, have been taught to speak human languages, at least by means of sign language. Coco used sign language to tell jokes and frequently pranked her handlers. At one point, she tied a zookeeper's shoelaces together. So gorillas are at least as intelligent as Bo, Larry, and Curly. And more philosophically, when asked where we go when we die, Coco sighed a comfortable hole and then blew a kiss, which I think is kind of an amazing response. Dolphins, of course, are also very intelligent. Among other things, they play, they use tools, they have names for each other. And those are just mammals. It's a little harder to recognize. Well, squirrels are mammals too, of course, but I think squirrels are much more intelligent than people think. My theory is that if you put a squirrel-proof bird feeder on the moon, squirrels would develop space flight in a week. So, they're the most, mammals are the most like us. Birds, our common ancestry with birds goes back very, very, very far. They are dinosaurs. Ravens are famously about as intelligent as a second grader when it comes to solving problems, especially if those problems involve annoying people or getting food. And parrots, like Alex Pepperbird, probably the most famous parrot of all time, have long been known for their ability to mimic human speech. But the woman in the picture with Alex, that's Dr. Irene Pepperberg, taught Alex to actually speak. He could look at a plate like the one she was showing him, and she could ask the question, "Can you show me show me an object that's red, or show me, which object is bigger, which object is red, which object has three corners," that kind of thing. There's a really good video about that Neil deGrasse Tyson made about Irene and Alex Pepperberg. I have a link to it in like my last slide, but and those results have been repeated with other birds right now. By the way, this species, African gray parrot, is supposedly the one that is most extraordinary in its abilities. But the point is that Alex was considered to be kind of a bird Einstein, but it's looking more and more like he was just a bird any other guy. I mean, he just was showing abilities that parrots have. So birds, sure, but what about their reptile relatives? You may remember in the original Jurassic Park movie, the scene where the game warden, I think his name is Muldoon, right? The Aussie guy with the hat, where he announces very portentously that the raptors are super intelligent, saying they never attacked the same place twice. They were testing the fences for weaknesses systematically. They remember. Well, anybody who works with alligators knows that alligators do that when they're in captivity. So they'll tell you, and are they hyper intelligent? And so, well, okay, but these are all vertebrates, right? It gets weirder. Surely not arthropods or mollusks, but the point is, or the fact is that yes, the intelligence of octopuses is becoming pretty widely known and better documented. By the way, octopuses is the correct plural. I looked it up, writing this up. Unlike all our previous examples, octopuses are not particularly social in nature. So they develop this intelligence as solitary creatures. That's a real different kind of intelligence. This spider is an Australian jumping spider. Um, they've been shown to have dreams. I guess their eyes move like a dog's when they're sleeping. And also to recognize different humans. And my personal favorite is the soccer playing bees. Um, I'm not sure what led some researcher to decide to do this, to decide like I'm going to teach the girls to play football, you know. But he did so. He used a bee puppet to teach his initial group of bees to put the ball in the net for a reward. I wonder whether the bees like slide across the pitch. They take their shirts off and slide across on four knees while taking their shirt off with the other two limbs. But what's really amazing is that after a while, the puppet became superfluous because the veteran bees started to teach the new bees to play soccer. Uh, and of course, that's fairly close to what they do in the wild. Bees communicate the location of nectar by dancing, right? To indicate the direction. And then, you know, if you think that's already getting weird, then there is the so-called wood wide web. This is so. I have to tell you this story very quickly. When I was in college, I took a creative writing course with a famous writer, Joyce Carol Oates, and she had a very like flat Midwestern accent. Remember, someone in the class wrote a story about Christmas trees in a lot where they were sort of personified, like, oh, somebody just caught Bill, you know. Wonder what's going to happen to Bill. And someone after we read the story, someone in the class said, like, do you ever wonder whether trees really think and talk to each other? And Joyce Carol Oates said, well, trees have a very limited consciousness. That was her verdict on that, and that's what I remember from the class. But recently, a popular theory arose that trees actually do communicate not only oak to oak, so to speak, but intraspecifically and even intra-kingdom with fungus, and that the forest is a web of roots and fungal mycelium uniting underground, transmitting information about nutrients, threats, and so on. Now, I tend to agree with Professor Oates on this one. I think the wood wide web seems a little bit over the top, and is perhaps driven by close connection the researchers feel with their subject. I have to say, I didn't make that term up. That exists previously. If you really want it to be true, as I do, it's probably not, right? Still, trees which not only lack a brain, but any kind of nervous system, do respond to stimuli in ways that seem beyond the mechanisms they have, and we don't know how or why. So how are we ever going to recognize, you know, where intelligence begins? As mentioned earlier, our anthropocentrism causes us to miss signs of intelligence different from our own and overvalue our own. As per my favorite way of putting this, humans think, and they think other creatures don't think, right? This is a huge problem when recognizing potential alien intelligence. Consider this bird here. This is a sage grouse. Every spring they gather at these traditional staging areas called leks, L-E-K. There, the males puff out their chests, making booming sounds from these inflatable air sacs. They spread their tails out and strut around like they couldn't be more proud of themselves. And the females, you can see the females here, sort of walk around them, check them out, like judges in the Westminster Kennel Club, and eventually pick a mate. Stage grouse, by the way, operate strictly on a one-night stand basis, and then they go off and get a room somewhere. So we look at them and think, silly animals doing this ludicrous dance, going through the steps completely without thinking, slaves to their instincts, and yet we do the same thing, posturing elaborately, performative outrage, trying to win your vote by virtue of superior couture and greater snarkiness. And research has shown that the mates chosen by female sage grouses are the ones most likely to father successful chicks, whereas human voters have a more checkered record. So the news is, though, that we're making some progress. There are definite signs of human intelligence. One is that instead of teaching animals to speak our language, we are, for the first time, making substantive process towards understanding another creature's language. In this case, the language of sperm whales. They communicate with each other by means of clicks. This is natural for them. It undoubtedly evolved from their use of clicking in the process of hunting giant squid in the depths of the ocean, where they make that sound for the purpose of echolocation. It seems a natural next step that they might use those sounds for communication amongst themselves. They live in tight-knit matriarchal clans, not unlike elephants. So identification is a natural next step. What clan do you belong to? I'm sorry, they have a vocabulary of short rhythmic words, quote unquote, called codas. By the way, as a musician, I do not like that use of the word coda because it means something very different in music. But that's how they communicate. And scientists have started analyzing these codas. This very complicated chart here shows some of the research done on their codas and how they're used, particular members of a particular clan who are color-coded. So these codas, you can sort of see the rhythmic patterns here. This is plotted out roughly by time, and all of these things represent words. The other interesting thing is that they differentiate their codas not only by rhythm, but by like the vowel sound, which I'll get to explain in a moment, and also by the inflection, because when they make those codas, they also make a low kind of moaning sound. And the moaning sound will sometimes go up or down, they are essentially could be using those to make complicated words. I couldn't quite, but the bug we were having earlier had to do with the fact that I could not play sound in this video now in order to be heard by the people online. But you may know that vowel sounds in human speech that make a very big difference between, let's say, ram, ream, rem, room, right? That those vowels represent changing the overtone structure of your mouth. So that when you make a sound, you're actually not making one pitch, but every whole number multiple of that pitch. And if you start subtracting overtones here and there, you end up with sometimes a different vowel. That's how we make the difference between room and ream. And you can see in the sonograms of sperm whale codas that they do the same thing. All of these are versions, most of them are versions of one coda. Basically the click, 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 click coda. And you can see that, some of them have very low voices, that are higher pitched voices, and so on. And this is that low moaning sound. You can see the differences in inflection. I did have a video showing some sperm whales singing, but whoops, it's not going to work. There we go. But if you find these videos, you can listen to them, and you can hear in this particular one, they're all mostly making the same sound, same coda, but you can hear the difference in their voices. Some of it, presumably, is just the fact that some of the whales are. That, by the way, is that the breathing sound you hear is a diver, obviously. The breathing sound in the background of that was the diver who was filming that breathing. It's not the whales making that sound, but you could hear them clicking, and you could hear the higher and lower versions. Now they're just all swimming along, doing not much of anything. So I kind of think what they were saying was kind of like just keep swimming, right? But or saying their name over and over again like a Pokemon. But it is a question of how would we ever understand alien languages. And I picked this image because, of course, it is a language based on clicking, right? That Rocky there uses, and on frequency. What we have come a long way. We've made progress in this, and I just wanted to point out the way we thought about nowadays. Well, the way we thought about alien languages earlier when we had movies. If you've ever seen, Forbidden Planet. Oh, I just made a coda. The way, if you've seen Forbidden Planet, anybody seen that movie? Old, so it's older than me, science fiction movie. Right, and it's
many times.
Right. So in this scene, I'm just going to play like one line. Professor Morbius, of course, with a name like that, but that's Walter Pidgeon here, is and Leslie Nielsen, young Leslie Nielsen. He's explaining to these officers like that there once was a powerful alien civilization on this planet. That's what he's saying. And let's see if it works. Yep.
In times long past, this planet was the home of a mighty and noble race of beings, which called themselves the Krell. Ethically,
which called themselves the Krell. But later on in the movie, you hear their language, and it's kind of like the sound of if you had a magnetic tape of a concert, and then you walked past a really powerful magnet, and you played it at high speed, right? And then it doesn't sound anything like any form of noise that could produce the sound Krell. So you wonder, does their language, how does he know that they're called the Krell? What does the word Krell mean? Is it something from their language? Because it sure doesn't sound like it. Or is it, did you listen to the tape and hear like Krell, but at any rate, so nowadays when whoops, come on, we can do better than this.
that recall.
Okay.
Something was made.
So nowadays, when we make movies, we have carefully designed alien languages that are sometimes very, very detailed. This is of course Jabba the Hutt, and what he's saying at this point in the movie is Boshuda, right? Which is a word that is from a language described in the as Huttese, which is kind of funny. By the way, the word Boshuda, I looked it up, is supposed to mean essentially the same thing as live long and prosper, which is kind of weird coming from a dinosaur. So is there extraterrestrial life? Of course, if the answer is no, we'll never know, right? If the answer is yes, we probably won't know for a long time. But again, those maybes are beginning to pile up. So don't say we can never know. Just ask Auguste Comte what the stars are made of. So I think we can close there. Here's the URL for that Neil deGrasse Tyson video on Alex Pepperberg. Thank Alan Bonnie, as always, Cliff Ashcraft, who turned me on to speaking sperm whale codas and also to soccer playing bees, and Duca and NASA, many of whose images I used, and of course all